In this little video, I'm going to show you how to use, I'm sure I'm going to mispronounce this, but the Mahalanobis distance and variance computational method for detecting and removing outliers. Well, I guess it's really a detection method, but then I'll show you how you can remove those outliers as well using SAS. So before we get into that, I want to show really briefly what we're doing here with the SAS code. So we've got some includes, and these include files. The one that you'll really need for this d squared or Mahalanobis distance method of removing outliers is an outlier.sas file. So if this is hosted on my own computer here, but if you need it, you can always Google outlier.sas, Mahalanobis. Here, let me put this in here. Okay, so what I'm doing here is just putting in a comment so you can see how it's spelled. So if you want to Google this yourself, Mahalanobis d squared method for outlier detection. It's a really cool method of finding outliers in your data set, and then you can, from there, you can extract or delete those outliers from your data. So we're including this here. I'm including a couple other things, honestly, that my instructor told me to include. CQ plot, I believe this will allow me to do histograms, the labeling. I'm not really sure what that does, but I've got them in this set just in case. And then this whole block you see here, this is just clearing out all of the previous work. So each time I run this in the output window, I want it to be cleaned and cleared. That's what this code is doing here. And then what we're doing in this spot here is we're reading in the data. So this first line in file calls up the actual data set, and swb-usa.dat. Again, if you Google that, you can find the file. What this data is there's 1,181 respondents in the United States that completed a satisfaction with life survey. And there were 5 different data variables across 3 different aspects. So the first aspect was a measure of their life satisfaction. And they were asked questions such as, is my life close to ideal? Are the conditions of my life excellent? I am satisfied with my life. And then they ranked it 1 to 5, 1 being strongly disagree, 5 being strongly agree. So that is the LS parameter set, or variable set, I should say. And then the PA set, this was, let's see, it was positive effect is what it was. And this was asking questions such as, how often do you find yourself clear-headed, confident, enthusiastic? And then lastly, the NA1 through NA5 variable set, this was negative affective states. So looking at confusion, depression, hopelessness, asking them the same questions. How often do you find yourself depressed, confused, hopeless, etc.? Okay, so these are all the different inputs that we're pulling in. And then you'll also see that we have an ID variable. So this is just ID of the survey respondent. And then below are all of the commands I'm using in this data set. I'm going to briefly go through these just so that you're aware of what's happening in the output. Data, so I'm not renaming the data. I'm not really changing the data here. So just adding to the current data set, SWB. The set is SWB. I'm titling it. What I'm doing here is I'm creating some new variables. A variable for mean through the formula mean that is provided by SAS. Then I'm also directly computing this, just adding them all together, dividing by 5 the number of variables. The reason why is the instructor wanted us to see that this computed mean can sometimes break, and it breaks if there are missing variables in your data set. So it's actually better to use the mean provided by SAS in this instance. So I'm creating 6 new variables in the data set, and I'm creating them for each of the response variables. So then I'm going to print that out. And then the next thing here, what we're doing is we're calculating some variables for the full data set. So we're calculating the full sample means, full sample mean per each of the variables that we created up here. So formula for life satisfaction, positive affect, negative affect, we're calculating those here. We're also doing the same thing for standard deviations, using the standard deviation formula. And then we're doing the same thing for correlation, checking for correlation between the different variables. Okay, so that's pretty common sense. What I'm going to do actually is show you what that looks like, and then we're going to go into the process of this Mahalanobis or d-squared outlier detection. We're going to look through the computational method, how that's done inside SAS right here. But for the purpose of showing you very clearly what I've done, I'm actually going to cut this from the data for now. I'm going to paste it over in a notepad I have open somewhere else so I don't lose it. And I'm going to run just this, so you can see what the outputs are that I've currently got. So even though we have 1,100 some odd observations, I told the system to only run the first 20 observations. You can see the data here, these columns here up through NA5 that came with the data set. And then we're looking at formulated means, computed means for LS, life satisfaction, positive affect, and negative affect. So we're looking at all the means. Computed LS, you can see the problem here. There are missing means because SAS chokes on these missing values here in the table. Okay, so that is that. Then we have the other components I showed you, sample means calculated for each of these parent variables, I'll call them, or I guess response statistic variables. And then we have standard deviations for the same sets. We're looking at correlation between the same sets. Correlation here, you can see that none of the correlations are super dramatic. I mean, 0.21 up to 0.26. There's not great correlation happening between these data sets. But the question is this because there are outliers? We always need to check our data set for crazy, ridiculous outliers. So this is how you do that. I'm going to bring this up again. I'm going to paste my code back in and explain to you what I'm doing, what I've already done, and then I will show you a new sample set. So first of all, I have run the outlier detection, the d-squared Mahalanobis. I'm sure I am killing that pronunciation. Okay, so what I'm doing is, before I added this line in, I first just ran this line, the outlier line here. So this outlier is calling the function that we've included up here in the outlier code, outlier.sas code. So it's calling that function and passing in the variables. Data is SWB scrubbed. So we're creating a new data set here. So I'm not actually changing the original data set. I'm just changing a scrubbed data set. And then I'm saying the variables we want to be checking for outlier status, I guess you would call it. The variables are these LS ones, so life satisfaction. We have to give it an ID because this is actually going to plot a scatter plot for us and mark on that scatter plot the IDs of the outliers that we can then use to delete those outliers in this first line here. The p-value, what we're looking here is we want a probability of about 0.05. Okay, and we're looking for anything that falls outside of that to make sure it's statistically significant. Okay, so what we're doing is we're taking 0.05 and then we divide that by the 1180 some odd samples or responses in this data set. And we come up with a gnarly number. If we move the period 5 times to the left, we come up with 0.00004. Okay? So that is the p-value that we've set in here. This is just really checking for anything that fits outside of this. And the passes, this is telling SAS to run through this once and look for stuff, and then run through it again and look for the different components that are outliers. So we did that for the LS 1 through 5 variables, and we found, I think, these first three IDs. So these are observations in the data set, ID number 28, 905, and 1055. It took 2 data passes to find these. And then for the second one here, looking at the positive affect variables, we identified all of these variables, a whole bunch of new ones that we needed to take out. And then we're going to run this again for the negative affect. So I'm going to show you how we do that here. So first things first, we just copy this. We change the variable names to reflect the negative affect. As such. Okay. Passes. For now, we're just going to do one pass and see what this returns. So, all of this done. I'm going to go ahead and save it just so I don't lose my work. Click submit or run. Takes a while because it's making multiple passes for all the previous ones. Okay, so what we will see is we see all of the data, the content up to this point here that I've already shown you. And then it's showing you the detections for outliers that are happening here in that first run. And then it's looking, so the first time I ran this, it returned a whole bunch of outliers on this graph up here that I have already taken out, thus they're not showing up. Same thing here with the second pass. It runs through all of these again, runs the d-squared computational method, and it provides this scatter plot, if you will. These might look like outliers, but they're what is it? The distance squared and the probability it's within bounds. So we're leaving those as is, but I've removed probably 10 different outliers. Then this data is clean. Then if we come down to this new one, so what you'll see here is we have this extra table. It's passing us this, and it's saying all of these different results or observations in your data. 31, 154, 243, 287, 327, 610, 675, 724, 1134. All of these may be outliers. But it's identifying one that is definitely an outlier. The distance squared, 1,113, where the rest are hovering, down here we look under 10. This is definitely an outlier. So we are going to nail this guy. We're going to take it out. If we look down here at the graph, we will see that they've identified a single variable of 154. Okay. So what I do here is I come back in, and I'm going to add to this ID line up here. So I do a pipe as an OR statement in SAS. I do ID equals 154. What this is doing is it's saying if the ID record equals 905, or if the ID record name equals 1055, yada yada, all the way up to 154, then we're going to delete that line. And it's taking it out of the SWB scrubbed data set. Okay? Not the SWB data set. So That's an important distinction we're making. And we're going to run this again. So what I'm doing here is I'm incrementing this by 2. I'm going to run another pass. And then I'm going to see what extra variables it gives us as an outlier, and then we can remove that. One caveat I need to mention is the way that I've structured this, where ID equals, and then the ID name or number, and then a pipe. There's got to be a better way to do this. I'm not sure what it is. This is honestly one of my first jumps into SAS. So just keep that in mind as you are doing this yourself. So I'm going to rerun this, and we'll see what extra variables it comes up with now when scrubbing for the negative affect. Okay, there we go. All of these numbers that have been identified are probably all outliers. So I'm going to come back up to this table up here and check those out. Okay. These DS squareds are a lot lower than that 1,100 some odd, but they're still higher than the rest of the data set. The probabilities are still considerably lower. So I am going to come in now and remove these different ones that have been identified here. So the way I do that is SAS, kind of annoying. I have to move this here. I'm going to come and look at this. Well, you know what I'm going to do? I'm actually just look at the numbers in the graph itself. I'm going to pick out the high ones. I might leave some of these lower ones in and do another pass just to see if it comes back as having removed them. So pipe ID equals, I'm going to copy that because I'm going to do it over and over again. So ID equals 1134, paste, 39, paste, 287, paste. Okay, now they're getting bundled together. I see 243 though in there. Paste 321. I see 724, 610, 276. And that's all I'm actually seeing. So I'm gonna just go with that for now. Okay. So let's save that and rerun it. I should increase this passes to 3 since I've run another pass through it. But we're getting to a point where we're starting to remove these outliers, and these ones that remain are probably not extreme outliers, where they're ones that we need to really worry about. They are more natural outliers that kind of are a result of the actual data set, something in the data. So I have run this 3 times. Now I should have incremented that. It doesn't greatly affect this though, it's fine. So I come back to this, removing some additional 675 is one I want to take out, 31 I want to take out, 275, 222, and there's one more in here that I cannot see, so I'm going to pull this up anyhow. I think it says 221, but I'm going to confirm that. Did it come up here, and then we see it is 621. Okay. Way different than 221. So 621. There we go. I'm going to save this now and rerun it. There we go. So it has not labeled any of these as being outliers. And if we come to the top, we're not going to find a table with them in it. So I don't think we won't. So the Mahalanobis computational method has helped us to identify a dozen or so outliers, and we have removed them. Ultimately, we've removed, I don't know how many this is here. There's probably about 30 different responses in our data set that we've removed as part of these 3 Mahalanobis computational methods that we've run here. So that's how you do it. I hope you see how exciting this can be, where you're getting clean data now, and when we rerun the means and standard deviations and the correlation, we'll probably see a stronger correlation between all the different variables. since life satisfaction and positive affect and negative affect should have some correlation to each other. So that is how you do it.